All right. So this light frame construction that we're getting into, that you'll see heavily in chapter 3, um, frame construction, masonry construction, metal framing, and regional variations. Because obviously, depending on where you're at in the planet, you may build a little bit differently than another. So residential and your light commercial construction is going to include your wood frame construction, masonry, and your metal framed. So that frame, regardless of the material of which it is constructed, must be able to withstand all of the live and dead loads exerted on the building. And we'll get more in depth on what exactly live loads and dead loads are. But of course, customarily, uh, we have objectives that we want to make sure we take away after we get done with chapter 3. Those being, want to be able to identify fundamental principles of the platform framing, describe common methods of framing construction in addition to platform framing, identify fundamental principles of monolithic concrete construction, list and describe common types of unit masonry construction, 5, identify fundamental principles of metal framing, and 6, describe regional considerations for light frame construction. So the most common type of light frame construction is the platform framing. And platform framing is, or also known as Western framing, is a framing method in which each story of a building is uh, a unit framed by itself as a unit consisting of its walls, joists, and also its subfloor. Again, that's a framing method in which each story of a building is framed as a unit consisting of its walls, its joists, and also its subfloor. Now, your platform framing is an efficient and an inexpensive method for assembling and erecting residential and light commercial buildings. And wood or light gauge steel framing members form the framework in platform framing. And you can get a real good idea of what that looks like here in this rendering to the right. So in typical platform framing, you're going to make use of a sill plate, and that sill plate is going to be fastened to the top of the foundation wall using an anchor or anchor bolts embedded in the foundation wall. And those anchor bolts are available in sizes 3/8 up to 3/4 of an inch in diameter and about 6 to 24 inches in length. You're going to make heavy use of flat washers and nuts just to secure that sill plate to that foundation wall. And then your anchor bolts are commonly going to be placed every 4 to 6 feet on center, or the words OC on center. So as your joists rest on the sill plates, 2 outside joists align with the outer edges of the sill plates, and then the ends of all joists butt against a header joist. In your wide spans, joists are going to be supported by a steel or wood beam at the center of the building, as an OSB or oriented strand board that we previously been introduced to, or even plywood subfloor is going to be placed over and fastened to the joist using screws or even nails. Now your OSB or your plywood panels are going to be arranged in a staggered pattern at a right angle to those joists. And in addition to this, you can make use of construction adhesive, which may be used to secure that subfloor in positions to provide a strong and quiet floor. And then the subfloor extends to the outer edge of the joist and the header joist on all sides to form a platform. So, main takeaway here is that you're an oriented strand board or OSB, or make use of plywood subfloor is going to be placed over and fastened to those joists using screws or nails. And this is what we see an example here of a nail gun going through the subfloor and into a joist. Now, when exterior walls and interior partitions are erected, the bottom plates are securely fastened to the subfloor and into the joists below where possible. And then the bottom and the top plate corners and intersections are then fastened together. So while this assembly is stable and plummet must be permanently braced to withstand strong winds and other external stresses. So those winds will be considered horizontal forces acting upon the structure. So plywood or your OSB sheathing or your metal straps may be used to brace exterior walls more securely. So your plywood or your OSB panels are going to be fastened to those studs at each end of that wall to provide that, again, that lateral strength. And the remainder of the wall is going to be sheathed with that fiberboard or rigid foam insulation or even plywood or OSB panels, again, just to shore up that structural adherence against the horizontal force. Now with diagonal metal straps, they're going to be fastened to the exterior edges of the studs at about a 45-degree angle at each of those corners. And again, sheathing is going to be placed directly over the metal straps and fastened to those studs in those plates. Okay. Main takeaway is that your plywood or your OSB sheathing or your metal straps may be used to brace your exterior walls also. So basic structure is going to be modified to provide a stairwell and your chimney openings in the floors, and also your ceilings, your windows, and your door openings in those walls. In additional strength under bearing partitions. So your floor and your ceiling openings for stairwells or your chimneys must be located according to the prints or the construction documents you receive, regardless of the joist arrangement. So appropriate joists are cut and they're going to be reinforced by double trimmers, or also known as double joists at the side and at the double headers at the ends. So your door and window openings, regardless of their size, are located as shown on your prints, even though those studs are spaced 16 inches on center. Now, where your door and your window openings are required, those studs are going to be removed and replaced by your trimmer studs at the sides to support your headers over each opening. Next, you have your framing doors, and your framing doors and your framing of your window openings can be accomplished in several different ways, but the principle involved is to transfer the load imposed above the openings to the floor supports below and to provide the proper size rough openings. So where your bearing partitions are going to be placed parallel to the floor joists, double or even triple joists are going to be placed under the partitions to carry that load and transferred from the structure above down into the ground below. Okay, again, example of when you're at the beach and you dig a hole, you put your feet in the hole and you go back and cover up your feet. And you know how you can sway back and forth, but you don't really fall over if you stay stiff. Okay, same principle here when dealing with structural elements and transferring that load to the ground below. Okay. Now, floor and roof trusses. Those could be fabricated components. Those prefabricated components commonly used in platform framing building are very much seen here. So your roof trusses are going to be available for your flat, gable, hip, and all your other types of roof. And roof trusses are going to be constructed at a prefabrication facility, transported to the job site on a truck, and then lifted into place with a mobile crane. Now, some of those prefabricated framing components, including various engineered wood products such as your box beams or even your stress skin panels, consist of components of solid lumber, plywood, OSB, or parallel strand board or parallel strand lumber. You might also hear the term PSL related to parallel strand lumber, thus creating wood structural frames in your structures. So a box or a box beam is going to be your hollow horizontal member used as a floor or even a roof support, or to span wide distances over your openings. And here we see a basic makeup of that box beam, with your plywood on the outside enclosing with the use of adhesive onto the the webs and the stiffeners to enclose each of those 2x members. It's just composed of 2x's, probably 2x4s or even 2x6, depending on what structural needs need to be met. Okay. Now, a stress skin panel. This is going to be a structural unit used in your floors and also your walls and also your ceiling systems that consist of plywood panels. They're going to be nailed and glued to a wood frame. So typically, stress skin panels are going to be framed with 2x4s, spaced out 16 inches on center, and then covered on each side of the plywood. And your plywood on the upper side of a stress skin panels is thicker than your plywood on the lower side. You're going to make heavy use of insulation, which can be used and may be placed inside those panels. You have ventilation holes, which are going to be drilled in the 2x4s for air circulation. Then we have that stress skin panels are primarily used to span wide distances between your supports. Okay, stress skin panel. Now, balloon framing. This is going to be a multi-story framing method in which one piece of studs extend from the sill plate at the bottom to the double top plate above. Now, those upper floor joists are going to be nailed to the sides of the stud and receive additional support from a ribbon board that fits into notches cut into those studs. Your post and beam framing is going to be your framing method in which the basic framework of the building consists of vertical posts and horizontal or sloping beams. So that post and beam framing is characterized by wide expanses of glass, high ceilings that are actually the underside of the roof planks and heavy support members. So those ceilings are going to be finished to show the beauty of the wood itself, and the unique structural features of the post and beam framing are posts at the outside walls, beams below the floor, and beams above supporting the roof planks, and posts supporting the roof ridge. Another frame is a popular one, an A-frame. Don't see too much of it, depending on what region you're in. But this A-frame is a type of construction most often seen in vacation homes. And heavy framing members are going to be spaced 4 feet to 6 feet on center, which are going to be the main structural members. And the framing members resemble the roof beams of post and beam that we saw previously, except that they are placed at a steep slope and extend from the foundation where they are firmly fastened to the ridge. And then that roof planks are going to be strong enough to carry the roof load over the span between the structural members. So the exterior sides of an A-frame are actually roof surfaces and the 2 gable ends. So those gable ends includes your windows, indoors for your light, ventilation, and also your access. So we'll pause. Any questions before we continue on? Comments or questions?
No.
Okay, perfect. So prior to concrete being poured or placed for the footings, the forms must be properly laid out. So a trades worker is going to lay out the building lines from a point of beginning on the lot, and then the locations of the building lines are going to be marked on batter boards set back from the foundation location so they will not be disturbed during any excavation. Now, earth moving equipment such as a bulldozer is going to be used to excavate the lot to a specified depth. And then sufficient room is provided along the sides of the excavation for trades workers when erecting those forms. Now, where required, the size of the excavation must be shored up or even excavated to the proper angle of repose to prevent any type of cave-ins. So that foundation footing must be placed on undisturbed earth or earth that has been compacted to the proper specifications to prevent any sagging or settling of the finished structure. Now, most foundation forms that can be reused many times are going to be panelized. Your job built or your patented panel forms are going to be used to form foundation walls. Your job built forms are going to be constructed of plywood panels that are framed with 2x4s. Now, patented panel forms are going to be available from several different manufacturers and are easily assembled. Your patented panel forms are going to be constructed with something called Plyform or also HDO or high density overlay. Now, these are plywood panels with interlocking metal tabs for which metal frames are going to be faced with that Plyform panel and completing out your construction method in enclosing that foundation wall. So, but regardless of the type of patented panel form, the manufacturer recommendations for your panel placement and bracing must be carefully followed. Okay, you also have warranties and O&Ms related to making sure you do it the right way. Definitely don't want those things to be voided. Your foundation wall itself forms are they going to be well placed on the footer or on that footing, and it's going to be tied together with snap ties. Now that snap tie is just another patented tie system with a spreader cone to maintain your form wall while spacing and the wall ties together with that concrete while it's in place. And those snap ties are going to be broken off or you snap them at the break of the back after the form is going to be stripped. So you ever seen a concrete wall, you see those holes, those are coming from the spreader cones after they're snapped off. ICF. ICF is your insulating concrete forms, and they may be used to form concrete foundation walls in your residential and light commercial construction. And that ICF, or insulated concrete form, is going to be a type of concrete forming system that consists of a layer of concrete that's going to be sandwiched between EPS. So there's some advantages of the ICF construction, which include minimum air infiltration, reduced heating and cooling loads, which is very important, and better fire resistance. So your ICF components are going to be designed with interlocking edges that fit together or to utilize adhesive to hold them in place during concrete placement. So your plastic or even steel ties maintain that ICF spacing as your concrete is placed, and then the forms remain after the concrete is placed, eliminating the form removal time. Time and expenses in prefabrication all play a role ultimately on which is the best product and also what is the application of that product and type of building that you're trying to construct. So your foundation walls and your footings need to be waterproofed, and it can be waterproofed in various ways. And depending on the soil conditions, your footing depth below grade, and also the general climatic conditions of the area or the region that you're building in, methods for waterproofing your foundation walls include liquid membranes, asphalt sheet membranes, and rigid foundation waterproofing panels. So your liquid membranes are going to be applied by spraying or even mopping the foundation wall in the footing with a tar or an asphalt. And in some situations, wide sheets of polyethylene film are going to be placed over the liquid membrane to form an overlapping waterproofing cover. Now, your asphalt sheet membranes, those are going to be a self-adhesive. They're going to use a 60 mil sheet of rubberized asphalt laminated to that polyethylene film. And that asphalt sheet membrane provides good waterproofing capabilities when it's properly applied also. Now, your rigid foundation waterproofing panels, those are going to be placed over a liquid membrane that holds the panels in position until the foundation is then backfilled. Okay. Concrete stairways. Now, these are formed in several ways, also depending on their design. And one method of constructing concrete stairway forms is to erect a ply form or a HDO plywood panel along the sides and install and brace the riser form boards between those panels. So the riser form boards are going to be beveled along the bottom edge to allow full access to the surface of the concrete stair. And it's also going to be important when dealing with your finishing. Now, the panels and the riser form boards are properly braced to resist the pressure of that concrete as it's being placed, because it's going to want to bow out or bust out. Okay. Solid brick. Now, your solid brick walls, those can be constructed to carry the loads from the floor, ceiling, and also the roof joists also. So those walls are going to be laid with 2 withes of the brick bonded together every 6 course by a header course. And some building codes require a 12-inch wall of 3 withes for buildings more than 1 story tall. And joist ends are going to be fire cut. You know, this is a cut on an angle that we see at the top right. Fire cut. This fire cut is used to rest in the brick wall. So in the event of a severe fire, the burnt out joist drops without pushing the brick firewall outward. You have a square cut joist end would then exert a prying action, forcing that wall to fall. Now the joists are going to be tied to a masonry wall using twisted steel plates. Joist anchors, they're going to be placed at every 4th joist, and those anchors are going to pull out of the wall in case of a event of a fire. And the remainder of the structure is then constructed in the same manner as a platform framing. Your furring strips. Now your furring strips, or also your metal channels, those are usually installed on the inside of masonry walls to provide a flat and true surface for finished materials such as your gypsum board. And your furring strips, it could be 2 by 2, or your metal channels are going to be fastened to the brick using a powder actuated fastener. And then a space between the gypsum board and the brick wall provides ventilation for the wall. Now, moisture within that wall caused by condensation runs down to the flashing and is then directed out of the building through your weep holes in the mortar joists directly above the flashing. So when you go back and watch, you can pause it and take a great look at this detail. This is a common detail. Now, another typical framing method for building with masonry walls is going to be the use of steel columns and your steel beams to support your floor joists or your open web steel joists in place of a bearing partition. Now, in this type of construction, the structural steel members are going to support the roof loads, and the masonry walls between the steel columns are going to provide a low maintenance and highly secure exterior wall. Now, your masonry construction combined with your steel columns and beams is used for many light commercial buildings, such as your retail stores. So if you went to Chipotle or any type of retail store like that, you'll very much see this type of construction. Before we go, any questions, comments, or concerns about what we're covering so far? All right, let's keep pushing. Now, stay on the topic of brick. Now, this brick is often used in conjunction with a backup material of a different size, such as your CMU. So the brick courses and backup material must be arranged so that the wall is tied together at regular intervals. Okay. The main takeaway I want you to get from here is that brick is often used in conjunction with a backup material of a different size, such as your CMU. Brick, CMU, we have that airspace we talked about, and that brick header course that's being tied back into that CMU. The heavy, dark, circular dots representing your steel or your rebar lay within the concrete foundation footing. You see bits of mortar in between each course. This is graphic representation and graphic language. Okay. Now, when brick and CMUs are laid to make up a 12-inch wall, you have a full cut header and a brick header course that are going to be used to tie those walls together. So a full cut header is a special concrete masonry unit that is notched to receive the brick header course. And the backing wife is parged with mortar, and parging is a thin coat of mortar on a vertical masonry surface that's going to be used to provide a additional waterproofing quality. Okay. Cavity walls. We've seen it, we talked about it a lot, but your cavity walls are construction using 2 wipes of brick. A cavity wall is a masonry wall with at least a 2-inch airspace between adjacent faces, and that airspace increases resistance to that thermal and sound transmission. So ladder, individual, or even your truss ties are going to be used to tie the wipes together. And individual ties are usually embedded in the mortar joints of every 6 course at about, I think it was 24 inches on center. And continuous flashing is going to be provided in the same manner as for your SCR brick. Now, the core of the cavity may be filled with insulation to further increase the resistance to your thermal and sound transmission. And firm strips are going to be applied to the interior walls to provide a flat and true surface for your finished material like your gypsum board. Your cavity wall construction is going to be commonly used in buildings where the inside face of the exterior walls is to be finished with that exposed brick. Right? Something like the rustic brick look. In applications in brick veneer construction, 1 wipe of brick is used as a skin over wood, which will be seen in our brick veneer house. So with that 1 wipe of brick being used as a skin over wood or even a metal framed wall, natural stone or manufactured stone units, MSUs, may also be used to cover the framed walls. And the foundation must be wide enough, okay, it must be wide enough, see here at the bottom, to support that seal plate for the joists and also the brick or the stone. So the building framework is erected first, and it provides that support structure for the floor joists, the ceiling joists, and in the rafters. And the brick is then laid and tied to the frame wall with clips. And 1 clip is going to be required for each 2 square feet of area. You're going to make heavy use of 1-inch airspace. And that 1-inch airspace is provided between the wall sheathing and the back of the brick, because a slight movement between the brick and the frame wall will result due to shrinkage of that wood members inside the structural wall. Now that airspace also provides ventilation for that wall, and also flashing is used to divert any moisture built up toward the weep holes and placed in the brick joints. Okay. Pause that, look at this detail. I guarantee you will see it a lot over your careers. Now, your light gauge applications, making use of light gauge steel framing members. These are available in various shapes, various thicknesses, and various strengths. Common light gauge steel framing member shapes include your C shapes. It includes your tracks. It includes your U channels. And it also includes your furring strips or furring channels. So your C channels are the most common shape produced for your light gauge steel framing and are used for studs and also your joists. Tracks are going to be fastened to the ends of studs and joists in a manner similar to wall plates and header joists used in your wood frame construction method. Okay, from top to bottom, under the C shape, see the use of the flange with a web with a lip on the inside. Under the track, we have flange and a web. And you could technically say the same for the U channel with a use of the flange and a web. Okay. Now, non-load bearing walls, So your non-load bearing walls that are going to be constructed with your C shapes and your tracks are commonly used for interior partitions, hence non-load bearing, in your residential and your light commercial construction applications. So your wall sections are either laid out on the subfloor and then tilted up into position, or constructed in place by fastening the top and bottom tracks in position and then installing the C-shaped studs between them. So the tracks are going to be fastened to the floor and also the ceiling with nails, screws, or a powder actuator fastener depending on the surface material. And then the studs are going to be snapped into place at the specified or on-center spacing, which is commonly going to be 16 or 24 inches, and fastened with screws or crimped to stay in its position. Then you have installation, and that installation may be installed between those studs, and the electrical plumbing rough in may then begin. So after the rough electrical and rough plumbing work is installed and also inspected, your gypsum board is going to be attached to the studs and then tracked using a self-tapping screw. And your door frames are going to be installed in the framework whenever specified for those prints. Okay. Now, your floor systems for your metal frame buildings, those are going to be constructed in a manner similar to the wood frame buildings. So your C shapes are going to be used for your joists and are going to be available in several depths, anywhere from 6 to 12 inches, and several metal thicknesses. So your metal joist can rest directly on the foundation wall, or it can rest on a steel plate attached to that wall. So when joists rest directly on the foundation wall, your clip angles are going to be used to attach the rim track to the wall. And when the joist rests on a wood steel plate, you're going to make use of a metal plate, which is going to be used to fasten the rim track to the steel plate. So you have bearing stiffeners, which are going to be installed at the joist ends to prevent the ends from being crushed when those loads are then applied later on. Because this thing gets heavier and heavier as construction wages on. Lastly, exterior walls, which are placed on the floor joists and the subfloor, we're going to take a little look at, okay? So your exterior walls, which consist of your load-bearing studs, often referred to as heavy gauge framing members, with top and bottom tracks. So your solid C shapes or your C shapes with knockouts punched in the webs are used as your studs. And studs with knockouts allow the passage of plumbing pipes or electrical conduit. And your studs are going to be spaced at the on-center spacing specified on those prints, probably 16 or 24 inches on center. And use of inline framing is going to be commonly utilized when constructing load-bearing walls, inline framing. So your inline framing is a framing system in which all joists, all studs, and roof rafters are in a direct vertical line with one another, allowing loads to be directly transferred to the foundation. Racking loads, which are your distortions diagonally across the wall, are then counteracted by using structural wall sheathing at the corners or by using diagonal tension straps, okay, to help prevent against racking. All right. Any questions on the material covered so far? I have 7 o'clock. We covered a whole lot. Let's do this.